and you have cyclic compounds. Open chain compounds are also called as aliphatic compounds. So open chain compounds known as aliphatic compounds. They are further classified Okay, voice isn't coming, just a minute. Can you hear me now? Topic has been, no, today the timing for 3:30 was organic chemistry only. Okay, it was IUPAC only. Okay, today the topic was IUPAC. Anyway, IUPAC I don't think has been started. Or has it been started, IUPAC? Is this for JEE Shala student? No, it's for the YouTube. Online. For all students. Okay. Fine. So can I continue? Okay. Fine. So organic compounds, classification of organic compounds, you have two types. You have open chain and you have cyclic compounds. Open chain compounds are also called as aliphatic compounds, which are further classified into two types. You have saturated and you have unsaturated. A saturated organic compound is that which has no carbon-carbon double bond or any carbon-carbon triple bond present in the molecule. Okay, saturated compounds are those which do not have any carbon-carbon double or any carbon-carbon triple bond present in the molecule. Unsaturated compound, again these are further saturated organic compounds are known as alkanes. So, if they ask you what are alkanes, alkanes are open chain saturated organic compounds. Open chain, why? Because here the carbon atoms, they join to form a chain, and since they don't have any double or triple bonds, they are saturated. So basically alkanes are what? Alkanes are saturated open chain organic compounds. Unsaturated means it could have either a carbon-carbon double bond present or it could have a carbon-carbon triple bond present in the compound. If you have a carbon-carbon double bond present in the compound, then the molecule is classified as an alkene. And if the molecule has a carbon-carbon triple bond present, then the molecule is classified as an alkyne. So alkenes are molecules having carbon-carbon double bonds. Alkynes are molecules having carbon-carbon triple bonds. Okay. Saturated compounds won't have any carbon-carbon double, neither any carbon-carbon triple bond present in them. For alkanes, we know the general formula for an alkane is CnH2n plus 2. For alkenes, the general formula is CnH2n, and alkynes have the general formula CnH2n minus 2. Now coming to the cyclic compounds. Cyclic compounds are classified into, you have carbocyclic, which are also called as homocyclic. So in these compounds you will have only a ring of carbon atoms. No other atoms are going to be there inside the ring except carbon. So you have carbocyclic or homocyclic. Then if you have an atom other than carbon inside the ring, those compounds are classified as heterocyclic. Okay. Carbocyclic or homocyclic are again further classified into alicyclic and aromatic. Okay, alicyclic and aromatic. Aromatic organic compounds are those which have similarities to benzene. Okay, what exactly are aromatic compounds? We'll be doing the details of that in the next chapter. Anyways, here today we are going to start with the naming of these different types of organic compounds. That is the IUPAC nomenclature of organic compounds. Okay, so this is the classification of organic compounds. I repeat, you have open chain and you have cyclic compounds. Open chain compounds, organic compounds, are also called as aliphatic compounds, and aliphatic compounds are further classified based on whether the molecule is saturated or unsaturated. A saturated organic compound will have no carbon-carbon double bond and no carbon-carbon triple bond present. Unsaturated organic compounds will either have a carbon-carbon double bond or a carbon-carbon triple bond present. If the molecule has a carbon-carbon double bond, then the molecule is classified as an alkene, and if the organic compound has a carbon-carbon triple bond, then the molecule is classified as an alkyne. I have given you the general formulas here for alkane, alkene, alkyne. Alkanes have a general formula of CnH2n plus 2, alkenes CnH2n, and alkynes have a general formula of CnH2n minus 2. Coming to the cyclic compounds now. Cyclic compounds again are classified into two types. You have carbocyclic, also called as homocyclic. In these compounds, you'll have a ring made up of only carbon atoms. Okay, so if the ring is made up of only carbon atoms, then the compound is classified as a carbocyclic or homocyclic. The other classification is the heterocyclic compounds. Heterocyclic compounds would have a heteroatom. That means an atom other than carbon present inside the ring. Say for example, I take this compound. This compound, in addition to carbon, there is a nitrogen. So this can be classified as a heterocyclic compound. Okay, so heterocyclic compounds would have a heteroatom. Heteroatom could be nitrogen, oxygen, sulfur. So these atoms could be present inside the ring along with carbon. Fine. So now let's begin with the IUPAC nomenclature. Okay. Now before I start that, we know that carbon forms innumerous compounds. Innumerous means you can't even imagine, and that is why we had this separate branch of chemistry to come up, that is organic chemistry. The reason is because of the unique property of carbon, which is called as catenation. You know, catenation is nothing but ability to bond with itself. Carbon has this unique property of catenation, that means its ability to bond with itself is extensive. And the reason behind that is carbon-carbon bonds are the most stable single bonds. In other words, the bond energy of a carbon-carbon bond is maximum. And that is why when carbon-carbon bonds are formed, energy released is also very high. And you need very high energies to break a carbon-carbon bond. Okay, so this formation of these innumerous organic compounds is because of the unique property of carbon, that is catenation. We also know that carbon forms 4 bonds because the number of valence electrons present in an atom of carbon is 4. So in order to complete its octet, it needs 4 more electrons, and that it prefers sharing by forming 4 covalent bonds, and it completes its octet. Okay, so now let us begin with the IUPAC nomenclature of organic compounds. Now the IUPAC system, which stands for International Union of Pure and Applied Chemistry. This system is formed by the UNESCO. Okay, so IUPAC system is formed by the UNESCO. IUPAC stands for International Union of Pure and Applied Chemistry. So it's a standard system used throughout the world for naming of organic compounds. So basically standardization of the naming is given by the IUPAC system. Now the IUPAC system has divided the name of an organic compound into 5 different parts. The central part in the IUPAC system is called as the root word. The central part is called as the root word. Before the root word, you can have a primary prefix. Before the primary prefix, you can have a secondary prefix. I said you can have. You can have means the primary prefix and the secondary prefix. It is not compulsory that it will be there in the name of the organic compound. So the basic necessity for an organic to be naming an organic compound is the presence of a root word. Root word is going to always be present in the naming of the organic compound. When we start naming, you will understand. Now root word is always followed by a primary suffix. So root word is always followed by a primary suffix. After the primary suffix, you may or may not have a secondary suffix. But these are the 5 parts which are used in the naming of organic compound. The essential part of naming, that means compulsory, the part which is going to be there in the name of the organic compound is the root word and the primary suffix. Okay. Now these will depend on the structure of the organic compound. That means the primary prefix, secondary prefix and secondary suffix may not be there in naming of organic compounds if those particular identities are not there in the organic compound. Okay, first let me start with the root word. This is the basic essential part of the naming, the root word. The root word indicates the number of carbon atoms present in the longest chain of the compound. Longest chain is also called as the parent chain. Okay, longest chain is also called as the parent chain. So root word gives us the number of carbon atoms present in the parent chain of the organic compound. What does the primary suffix tell you? The primary suffix, this indicates whether the organic compound is saturated or unsaturated. Okay. So the primary suffix indicates whether the organic compound is saturated or unsaturated. If the organic compound is saturated, then the primary suffix to be added is always ane. And if the organic compound is unsaturated, then depending on unsaturation, whether you have a carbon-carbon double bond or a carbon-carbon triple bond. For a carbon-carbon double bond, the suffix to be added, the primary suffix which you will be adding is -ene. And for a carbon-carbon triple bond, the primary suffix which you would be adding is a -ine. Okay, we'll come to all these. First, let me just tell you what all these 5 parts indicate. Now coming to the primary prefix. The primary prefix, this indicates whether the parent compound is cyclic or open chain. Okay, so this tells you whether the parent compound is cyclic or open chain. If your compound is cyclic, then the primary prefix used is cyclo. But if the compound is open chain, you don't have to have a primary prefix. Okay, so primary prefix is not an essential part of the naming. This will be essential only if your organic compound is cyclic. Okay, now coming to the secondary prefix. Secondary prefix indicates what? This indicates the substituents present on the parent chain. Substituents present on the parent chain means the branches. Those carbon atoms which are not a part of the parent chain, those are classified as substituents, and those are named always as secondary prefix. Now coming to the last part of the naming, that is the secondary suffix. The secondary suffix indicates the functional groups present in the organic compound. Okay, so this indicates the functional groups present in the organic compound, the main functional group. Okay, so these are the 5 parts in the naming. I'll be first starting with the root word, that is the central part. Okay, so let's begin with the root word. Fine. Now, as I have told you, root word indicates what? Root word indicates the number of carbon atoms present in the organic compound. If your organic compound has, say, only 1 carbon, then the root word assigned to that is meth. If your organic compound has 2 carbon atoms, then the root word assigned to that is eth. For 3 carbons, it is prop. For 4 carbons, we use the root word as but. For 5 carbons, we use the root word as pent. 6 carbons, it is hex. 7 carbons, hept. 8 carbons, oct. 9 carbon, non. 10 carbon, you have dec. 11 carbon, undec. 12 carbon, dodec. For 13 carbon, you have tridec. 14 carbon, tetradec. For 15 carbon, you have pentadec. 16 carbon, hexadec. For 17 carbon, the root word is heptadec. For 18 carbon, you have octadec. 19 carbon, nonadec. And for 20 carbon, the root word is icos. Okay. So the maximum you should know is, I think, not more than 15 carbons. Okay. So 15 carbons, if you know the root words, it is more than sufficient. They are not going to ask you beyond that. Okay. So this is a root word. Basically, root word tells you the number of carbon atoms present in the longest chain. If your longest chain of carbon atoms, say, has 9 carbon, then the root word you're going to use is non. If your organic compound, the longest chain in the organic compound has, say, 15 carbon, then the root word which you're going to use there is pentadec. Okay. So root word indicates the number of carbon atoms present in the longest chain of the carbon, that is the longest chain of the compound, that is the parent chain. Now the root word always has to be followed by a primary suffix. So primary suffix and root word is always going to be there in the name of the organic compound. Okay. So now what is this term primary suffix? As I've already told you, primary suffix indicates what? Primary suffix tells you whether your organic compound is saturated or unsaturated. If your organic compound is saturated, that means if there are no carbon-carbon double or triple bonds in the molecule, then we classify the compound to be saturated. A saturated organic compound will always have a primary suffix of "ane". So the primary suffix there has to be used as "ane". For an unsaturated organic compound, again it will depend whether the molecule has a carbon-carbon double bond or it has a carbon-carbon triple bond. So for a carbon-carbon double bond, the primary suffix which we use is "ene", and for a carbon-carbon triple bond present in the molecule, the primary suffix to be used is "ine". Okay. So the two main components of naming an organic compound is the root word, which indicates the number of carbon atoms in the parent chain, and the primary suffix. Primary suffix will tell you whether your organic compound is saturated or unsaturated. So based on this, now we can start with the naming of organic compounds. Let us begin with the simplest organic compound with only one carbon. One carbon, so all the four bonds of that carbon will be with hydrogen. Okay, so this is the simplest organic compound with one carbon. One carbon, so root word to be used here is meth. The root word which you are going to use here is meth. Now this compound doesn't have any carbon-carbon double bond, neither it has any carbon-carbon triple bond. So if it doesn't have a carbon-carbon double or carbon-carbon triple bond, that means the compound is going to be classified as a saturated compound. So for saturated compound, the primary suffix which I am going to use here is "ane". So the IUPAC name for this compound is methane. Okay. Now the next organic compound will have two carbon atoms. Two carbon atoms. You can see there is this bond, single bond present between the two carbon. So each carbon here is forming a single bond with the other carbon. So remaining three bonds it is going to form with hydrogen. That is why you have 3 hydrogen here and 3 hydrogen here. Total carbon in the compound are 2. So the root word I am going to use here is eth. Again, this compound doesn't have any carbon-carbon double bond, neither it has any carbon-carbon triple bond. So it is a saturated organic compound, and for a saturated organic compound, the primary suffix we add is "ane". So the name of this compound, the IUPAC name of this compound is ethane. Okay, let me add one more carbon to this. Okay, so now again this central carbon has formed 2 bonds with 2 carbon atoms on either side. So remaining 2 bonds will be with hydrogen. That is why there are 2 hydrogen here. Now here there are 3 carbon atoms in all in the parent chain. Yes, okay, 3 carbon atoms. So root word is prop. Again, no carbon-carbon double or triple bond. So the primary suffix which we are going to use here is propane. Yes, it's propane. Okay. Now from 3 carbon atom onwards, the organic compound can also be represented in a bond line notation. So what is this bond line notation? Let me explain. This what I have written for propane. I have shown the carbon and hydrogen, how they are bonded. So this form of propane is the structural formula of propane I have written. In bond line notation, these 3 carbon atoms, I am going to show them as 3 dots. I write these 3 dots in a zigzag way. And since there are only single bonds present between these, so what I'll do is I'll just join them by these single bonds. So this is the bond line notation of propane. So propane, either you represent it by a structural formula or propane, you can represent it by bond line notation. Bond line notation begins from 3 carbon atoms in alkanes. Why 3 carbon atoms? Because I cannot write a bond line notation for ethane. Ethane has only 2 carbon. 2 carbon means I cannot show it like this. This could also represent, say, a hyphen. Okay, so we cannot have bond line for ethane, neither for methane, because methane only 1 carbon. I'll have to write it as a dot. The dot could represent a full stop. Am I right? So bond line will always begin from 3 carbon atoms in alkanes. Okay, so this represents propane. If this is propane, then this compound will have 5 carbon. How 5 carbon? 1, 2, 3, 4 and 5. 5 carbon, so root word is pent. Again, there is no carbon-carbon double or triple bond. So no carbon-carbon double or triple bond. So so the primary suffix to be added is ane. So this represents the bond line notation of pentane. If you want to write the structural formula for pentane can be written like this. Okay. So this is the structural formula. This is the bond line notation. I can also write a condensed formula for this. Now just pay attention on how I am writing the condensed formula for pentane. The terminal carbons, that is the first and the last, we write them in the same way. There are 3 CH2 groups in between the carbon chain. So those 3 CH2 groups, you write them inside a bracket and put a subscript as 3 and then your CH3. So this represents the condensed formula. Okay, this is the structural formula, the bond line notation of pentane, and this is the condensed formula of pentane. Okay. Similarly, I can write one, two, three, 4, 5, 6, 7. 7 carbon atoms. So root word is going to be hept. It is saturated, no carbon-carbon double or triple bonds. So the primary suffix to be added here is ane. So this is going to be called as heptane. This is the bond line for heptane. I am writing the structural formula of heptane. One, 2, 3, 4, 5, 6, 7. And I also show the condensed formula of heptane as the CH2 group here is repeated 5 times. So this is the condensed formula of heptane. Okay. So this is how the naming of alkanes are done. Okay. So the 2 main components in the naming is the root word and the primary suffix. So these form the basic part of naming. Means the names of all the organic compounds should compulsorily have the root word and the primary suffix. These compounds do not have any secondary suffix because they don't have any functional groups. These compounds also do not have any primary prefix because these are all open chain. These compounds also do not have any secondary prefix because they don't have substituents. So the only 2 components present in the naming here are the root word and the primary suffix. Okay. So now let us proceed ahead. Okay. Now in this compound, there are 2 carbon atoms. 2 carbon atoms. So the root word I'm going to use here is eth. Root word I'm going to use here is eth. I can see that there is a carbon-carbon double bond present. So for carbon-carbon double bonds, the primary suffix which I have to use is ene. So the primary suffix I'll add here is ene. So the name of the organic compound becomes ethene. Yes. Okay. Now I can add a carbon here. This compound again has 3 carbon atoms. 3 carbon atoms. So the root word for this is going to be prop. We can see a carbon-carbon double bond in the compound. Yes. So the primary suffix to be added here is "-ene". Propene. So the IUPAC name for this compound is propene. This represents the structural formula for propene. The bond line for propene, you can show 3 carbon atoms with a double bond present between these two. You can also write it like this. It means same. Okay. This or this is same. So the double bond, you could show it on the left carbon, or you could also show it on the extreme right carbon. Both mean same here. Okay. Now this compound again has 4 carbon. 4 carbon, so root word I'm going to use here is but. Again there's a carbon-carbon double bond. So the primary suffix I add is "-ene" here. Okay. But there is something missing in this name. The reason is, what if I take this compound? This compound also has 4 carbon atoms. So the root word I'm going to place here is but. This compound also has a carbon-carbon double bond. So if it also has a carbon-carbon double bond, that means the primary suffix I'm going to add here is "-ene". So this is also butene. But I can see they have a difference in their structure. Here the double bond is present on the terminal carbon, but here the double bond is present in between the carbon chain. I repeat, here the double bond is present on the terminal carbon at the ends of the carbon chain, but in this case the double bond is present in between the carbon chain. So for such compounds I need to number the carbon atoms, and numbering will give me the exact position where the double bond is placed. Okay, so while numbering the carbon chain, we have to take care that the numbering has to begin from that end which is closest to the carbon-carbon double bond. Okay, so numbering has to be done for the carbon chain from that end which is closest to the carbon-carbon double bond. In other words, for this compound, numbering from left to right is going to give me the correct numbering. Numbering it from right to left is going to give me a wrong numbering. The reason is, so this is correct and this is wrong. The reason is because if I'm numbering from the left end, the double bond is getting position 1, and from this end the double bond is getting position 3. The first number you have to check. See, here the double bond is present between carbon 1 and 2. So you have to always indicate the first number. First number is 1 here. Similarly here, if I number from this end, I'll get the double bond being placed between 3 and 4. But I have to use the first number for naming. Should I name it as 1 butene or 3 butene? Naming it as 1 butene is correct, because the double bond should get the lowest possible number. So this numbering is the correct numbering and this numbering is wrong. So the name of this compound is 1-butene. You can also name this as but-1-ene. That means the ene group is placed on the first carbon. So but-1-ene or 1-butene. Between a number and an alphabet, you are supposed to place a hyphen. I repeat, between a number and an alphabet, there has to be a hyphen. Between a number and an alphabet, you are supposed to have a hyphen. Okay, so the name, IUPAC name of this compound is 1-butene or but-1-ene. For this compound, numbering from any end, that means from left to right or moving from right to left, will give me the same set of numbers for the carbon-carbon double bond, that is 2 and 3. So this is a symmetrical alkene. Symmetrical alkenes are those for which the numbering from left to right is same like numbering the carbon chain from right to left. So this is a symmetrical alkene and that is an unsymmetrical alkene. For unsymmetrical alkene, numbering from left to right and right to left is not same. Symmetrical alkenes, numbering them from left to right or right to left is going to give me the same numbers. So this is a symmetrical alkene. For symmetrical alkene, the numbering could be from any end. Now for this compound, I can see the double bond is placed between carbon 2 and 3. So I have to indicate the smaller number. So this compound is 2-butene, or simply you can write it as but-2-ene. Okay. So 2-butene or but-2-ene. Now the bond line I am going to make for this. There are 4 carbon. Double bond is placed on the ends of the carbon chain. So I am placing the double bond here. You could have also placed it this side. It's the same thing. For but-2-ene, you have 4 carbons again. The double bond is present in between the carbon chain. So this is the bond line for but-2-ene and this is the bond line for but-1-ene. Okay. So now proceeding ahead. Now for this compound, the numbering definitely has to begin from the left hand side, because if I start numbering from the left hand side, the double bond here is getting position 2. But if I start numbering from the right hand side, the double bond will be placed on carbon 3. So 2 is definitely a smaller number than 3, and that is why this is the correct numbering what I have given here. In all, the carbon chain has 5 carbon. So the root word I am going to use here is pent. Again, the organic compound has a carbon-carbon double bond, so it is unsaturated. And if it is unsaturated, I have to use the primary suffix as "ene" because of the carbon-carbon double bond. The ene group is present on the second carbon, so it is pent-2-ene, or you can also call it as 2-pentene. Okay, so pent-2-ene or 2-pentene. Now this compound has 2 double bonds. Of course, it has a ene group. Ene means alkene, but the 2 double bonds are there. So if there are 2 double bonds, it is going to be called as a diene. If there are 3 double bonds in a compound, it is a triene. If there are 4 double bonds, it is tetraene. 5 double bonds, pentaene. 6 double bonds, hexaene. 7 double bonds, heptaene, and so on. Now this compound has 2 double bonds, so I'm going to name it as a diene. Again, where the double bonds are there, which positions they have been placed. For that, I have to start numbering the carbon chain. Numbering of the carbon chain should give the lowest number to the carbon-carbon double bond. So if I start numbering from this end, the double bond is getting position 1 and position 4 from this end. What if I number it from the left hand side? From the left hand side, the double bonds will get position 2 and 5. 2 and 5, when you add up, it gives me the value as 7. 1 and 4, if you add up, the value comes out to be 5. When you add up, that number which you are going to get is called as the sum of locants. That number is called as a sum of locants. Okay. So left to right, if I am numbering, I am getting the position 2 and 5, which gives me the sum of locants as 7. And right to left, if I am numbering, I am getting the position for the double bond as 1 and 4. 1 plus 4 gives me 5. 5 is a smaller sum of locant than 7. So this is the correct numbering. Now, let us name this compound. In all, there are 6 carbon. 6 carbon, so the root word for this is going to be hex. Root word is hex. Again, there is a double bond, so it's a ene. But there are two double bonds, so diene. Which are the positions where the double bonds are placed? The double bonds are placed on carbon 1 and carbon 4. So the diene, that means the two double bonds are placed on position 1 and 4. Between two numbers, you are supposed to put a comma. Between a number and an alphabet, you are supposed to use a hyphen. Now, one more thing to be added here is, this is your root word, which is indicating the number of carbon atoms in the main chain. Root word is hex, and this is your primary suffix. This primary suffix here does not begin with a vowel. You know, there are 5 vowels, A, E, I, O, U. Here the primary suffix does not begin with a vowel. So if the primary suffix does not begin with a vowel, then after the root word, you have to add the letter A. I repeat, if the primary suffix doesn't begin with a vowel, then after the root word, you have to add the letter A. So the name of this organic compound is hexa 1,4 diene. Hexa 1,4 diene. If you want me to write the structural formula, this is going to be the structural formula for this. One, two, three, four, 5, 6. Okay, 6 carbon atoms. So root word hex. 2 double bonds. So diene. The position of the double bonds is 1,4. So it is hex 1,4 diene. But that letter A has to be added because diene does not begin with a vowel. So if the root word is not going to begin with a vowel, then we add the letter A. Sorry, if the primary suffix doesn't begin with a vowel, then we add the letter A after the root word. So now let us name few more. Okay, now this compound, if I number it from the left side, the positions for the double bond is 1, 3 and 7. But if I number it from the right side, it will be 1, 5 and 7. So 1, 3 and 7 is going to give me the correct numbering because I'm going to get a lower number, 1, 3, 7. So let us name this. There are in all 8 carbon. So root word is oct, octa, 1, 3, 7, triene. Okay, octa, 1, 3, 7, triene. Numbering has to be from this end. So this is 9 carbon, nona, 1, 4, 7, triene. Now this compound has 2 carbon atoms. Again 2 carbon atoms. So the root word for this is eth. It is unsaturated because of the presence of carbon-carbon triple bond. So carbon-carbon triple bond. So the suffix, the primary suffix which we are going to use here is ine. So the name of the organic compound is ethine. Three carbon atoms. So root word prop. Again, there is a carbon-carbon triple bond. So the suffix to be used here is "-ine", propyne. Four carbon atoms. Numbering will begin from this end because I can also have the triple bond in between the carbon chain. So numbering is compulsory here. This is 1-butene. Or you can also write it as but-1-ine. Now the bond lines I'm going to show you for these. From 3 carbon atoms, I told you the bond line. The bond line for propyne is going to be this. This is propyne. Why I haven't shown the zigzag manner of writing the carbon atoms? Why have I not written the carbon atoms in a zigzag fashion? The reason being, the carbon here is sp and this is also sp hybridized. This central carbon being sp hybridized, the bond angle here has to be 180 degrees. So this is the central carbon which is sp hybridized. The bond angle here has to be 180, and that is why you show it linearly. So in all there are 3 carbon. This is your first carbon, second carbon, and this is the third carbon. So that is why I have written it in a straight line, because the central carbon here is sp hybridized. Same way for this. This carbon here is going to be sp hybridized. Sp hybridized means this carbon, and this carbon are in one line. So there will be 3 carbon atoms in one line. This is 1, 2, 3. The fourth carbon you can show it downwards, or you can also show pointing it upwards. It's okay. Okay. So this is 1 carbon, 2 carbon, 3 carbon, and 4 carbons. So that is how you represent the bond line for alkynes. So in alkynes, for the carbon-carbon triple bond, those carbon atoms being sp hybridized, you draw those in a linear way. Okay. Even the carbon atoms connected to the carbon-carbon triple bond have to be written in one line, because since the hybridization of that carbon having triple bond is sp, it will be having a linear geometry with the other carbon atoms to which it is bonded. Okay. This is 2-butene. Numbering could again be from any end. So it is 2-butene, or you can also call it as but-2-ine. Writing the bond line for this again. These carbon atoms both are sp hybridized. So this bond angle is going to be 180. Same way this bond angle also is going to be 180. So all these 4 carbon atoms are going to lie in one line. So this is your butene, 2-butene. This is your first carbon, second carbon, third carbon, fourth carbon. First carbon, second carbon, third carbon, fourth carbon. So that is butene. Bond line for butene. Now supposing if I have something like this, how many carbon atoms I'll have to write in a linear way here? First of all, let me number this. Numbering again could be from any end, because it's a symmetrical alkyne. This is 3-hexyne, or you can also name it as hex 3-ine. Now this carbon and this carbon both are sp, so this bond angle will be 180. Same way this bond angle will be 180. In other words, these 4 carbon atoms will lie in one line. Okay. So 4 carbon atoms in one line. 1, 2, 3, 4. This side and this side you could show it like this, or you could show upwards also, or you could show one upwards, one downwards. It's the same. Now this compound again can be numbered from any direction, from left to right or right to left, because again it is a symmetrical alkyne. Now in this compound there are two triple bonds. Two triple bonds, so diene. Three triple bonds, triene. Four triple bonds, tetraene. Five triple bonds, pentaene, and so on. But here there are only two triple bonds, so it is going to be named as a diene. The positions where the triple bonds are present is carbon 1 and carbon 5. There are in all 6 carbon atoms. 6 carbon atoms, so the root word for this compound is going to be hex. Again, on the first carbon and the fifth carbon, you have two triple bonds. So it is going to be named as diene. Now, this is going to begin with a D. This is beginning with a D. So I'll have to add the letter A. So the name becomes hexa 1,5-diene, or you could also write it as 1,5 hexadiene. Now the question was, why didn't I put the letter A here? Because this is not a vowel. This is not a vowel. It is I. Why is not a vowel? You have 5 vowels, that is A, E, I, O, U. So why I didn't put the letter A here? The reason is, though this is not a vowel, but it makes the sound of a vowel here. Okay, I pronounce this as ein, not wine. Okay, since it sounds like a I here, it is taken as the letter I, and that is why we don't add the letter A here. Okay, but here, since this is not a vowel, neither it is sounding like a vowel, so I have to add the letter A here. So it is hexa 1,5-diene. Okay, now let's say this compound. This compound has both double as well as triple bond. So the compound has ein as well as ene. Alphabetically, ene, E comes before Y. So I'm going to write ene before ein. But numbering for this is compulsory because I'm supposed to locate where the double bond is there and where the triple bond is there. Numbering has to begin from that end, which again gives you the lowest number or lowest sum of locants for the double and triple bond. Lowest sum of locants I'll get only when I number this compound from left to right. Because if I'm numbering it from left to right, I'm getting position 1 here and position 3 here. If I number it from right to left, I'll get 2 and 4. So 1 and 3 will give me a smaller sum of locants as compared to 2 and 4. So this is the correct numbering. Now let us name this compound. There are in all 5 carbon. So root word here is pent. I am going to write ene before ein because in alphabetical order E comes before Y. The ene group is present on the third carbon. So it is pent 3-ene. And ein group is present on the first carbon. So 1-ene. Pent 3-ene, 1-ene. But one change again here has to be made. This is the root word. And these two, ene and ein, they are the primary suffixes. They indicate whether the compound is saturated or unsaturated. This is one primary suffix and this is also one more primary suffix. This is ending in a vowel and this is beginning it in a vowel. Now you will say this is not a vowel, but it makes the sound of a vowel, that is I. So when one primary suffix ends in a vowel and the other primary suffix sounds of a vowel, what I'll do is I'll have to drop this last E. So the last E here has to be dropped because I cannot place those two vowels together. Okay. So these are rules which you have to know and name the compound accordingly. So the name of this compound is pent 3N1-ine. Okay. Pent 3N1-ine. So that last E I had to drop because I cannot have those two vowels together. So this is the IUPAC name of the compound. Now for this compound again, the compound has both again a double as well as a triple bond. So there's a ene group as well as ine group. And if you look into the numbering here, the numbering from left to right, if I number it from left to right, I'll get position 1 here and position 4 here. 1 for the triple bond and 4 for the double bond. If I number it from right to left, again I'm going to get the same position 1 and 4. But this time here 1 will be for the double bond and 4 will be for the triple bond. So how do I name this now? Because I'm getting the same positions from either ends for the double and the triple bond. So when you have same positions coming for the double and triple bond, only then a double bond is given a higher priority over a single bond. So a double bond here will get a higher priority over a triple bond. This rule you will be using only when the positioning for the double and triple bond come out to be same from either ends. That means the same numbering comes out for double and triple bond from either ends. So for such compounds, the double bond gets a priority over triple bond. In other words, this compound will be named from that end which is closer to the double bond. Okay, so this will be correct numbering. The other way it is going to give me wrong. So this is the correct numbering. Let us name the compound. In all there are 5 carbon. So root word is pent. I have to name the ene first. Ene is on the first carbon. So pent, 1 ene, 4 ine. The last E I have already dropped here because of this sounding like a vowel. Okay, so the name becomes pent 1N 4 ine. Okay, now let's name this compound. In this compound again, numbering it from right to left and from left to right is going to give me the same name. So now again, which rule I'm going to use? The rule which states that when the sum of locants for double and triple bond is same, then the double bond gets a priority over the triple bond. So this compound I'm going to number it from the left end because the left end is closer to the double bond will get a lower number here. Now in all there are 8 carbon. So root word is oct. There is ene as well as ine. Alphabetically ene is to be written before ine, but there are 2 double bonds, so it's a diene. The position is 1, 5. Diene. I'll be using the letter A here after the root word because this is not a vowel. Octa 1, 5 diene, then 3, 7 diene. I have retained the E here because this is not a vowel. So the name of the organic compound is octa 1, 5 diene 3, 7 diene. So in these compounds you can see I have just used the root word and the primary suffix and I have given the name for the organic compound. Now let us talk about the primary prefix. Primary prefix that indicates whether your organic compound, whether the parent compound is cyclic compound or an open chain compound. Let us see what this means. Now if I take this compound has 3 carbon atoms. 3 carbon atoms, so the root word here is going to be prop. It is saturated because no carbon-carbon double bonds or triple bonds. So the primary suffix I'm going to add here is ane. And the name of the organic compound becomes propane. What if I take something like this? Okay. Now this compound also has 3 carbon atoms. 3 carbon atoms. So the root word for this compound is prop. I can see that there are no carbon-carbon double or triple bonds here also. So the primary suffix which I'm going to use here is ane, propane. But you can see there is a difference between the two compounds. Both cannot be written as propane. This has an open chain of carbon atoms where the two ends of the carbon chain are free. But this has a ring of carbon atoms, ring of 3 carbon atoms. So for such a compound, I am going to use the primary prefix, that is cyclo. Okay. So the name of this compound is cyclopropane. This compound doesn't need a primary prefix because this is not cyclic. So primary prefix will be used only when the compound is cyclic. So the primary prefix to be used here is cyclo. So the name of the organic compound is cyclopropane. The bond line for cyclopropane can be shown as a triangle. So a triangle represents cyclopropane in organic chemistry. A square would represent cyclobutane. A pentagon would represent cyclopentane. A hexagon would represent cyclohexane. A heptagon would represent cycloheptane. Now what if I show something like this? This is also a cyclic compound with total 10 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is cyclodecane. So the primary prefix tells you whether your compound is cyclic or open chain. Cyclic compounds would have a primary prefix here, that is cyclo. There won't be any primary prefix before a open chain compound. Now this compound again has 6 carbon. 6 carbon, so the root word I'm going to use here is hex. The compound is unsaturated because it has a carbon-carbon double bond. Unsaturated carbon-carbon double bond, so the primary suffix which I'm going to use here is ene. This is hexene. But I also know that the compound is cyclic, so I'm going to use a primary prefix here, that is cyclo. So the name here, IUPAC name, is cyclohexene. I don't have to indicate the number here. The reason is because even if I place the double bond somewhere here or here or here, numbering will not change because numbering will always begin from the carbon having the double bond here. Okay. So numbering will always begin from the carbon having the double bond. So I cannot have something like cyclohex 4-ene because numbering will always begin from the carbon having double bond. So it is always going to be cyclohex 1-ene. So that 1 you don't have to write because it's always going to be cyclohex 1-ene. Okay. So simply write it as cyclohexene. Now if I introduce 2 double bonds in the compound, then numbering is compulsory. The reason being, I can have different positions for the double bonds. I could have something like this. Now here the 2 double bonds are separated by 1 carbon. But in this case, the 2 double bonds are there on the adjacent carbon atoms. So here the positioning is, the numbering for the carbon, for the ring is compulsory. While numbering the ring system here, the numbering has to begin from any of the carbon here having the double bond in this case. So I could start numbering from here as 1, or here as 1, or here as 1, or here as 1. All are going to be same. Supposing I start numbering from here as 1, then I'm not going to go to the other double bond via this route, because double bond always has to be completely numbered. Completely numbered means if this is carbon 1, then the double bond is ending here, so this has to be carbon 2. So numbering it as 1, 2, 3 is wrong. First, if I've numbered this as 1, then the double bond is ending here, so this has to be 2. So this will be 3, 4, 5, 6. So this is how I'm going to number the first compound. For the second compound, the numbering, you cannot start from here as 1, because if you start from here as 1, then this has to be 2, 3, 4, 5. The other double bond is getting position 5, so that is wrong. What if I number it from here? It will be 1, then this becomes 2, this becomes 3, this becomes 4, this becomes 5, and this becomes 6. So you could start from here as 1, 2, 3, 4, 5, 6, or you could also start from here as 1, 2, 3, 4, 5, 6. Both are going to be same, and both will give you a smaller number for the two double bonds. So now let us name this 6 carbon. So root word is hex. Again there are two double bonds, so it is diene, hexa, 1, 4, diene. Since it is cyclic, I'm going to add the primary prefix of cyclo. Cyclohexaone is the IUPAC name, and for this compound it is going to be cyclohexaone. Okay. Cyclohexaone. For this compound again, we have to start from any of the carbon having the double bond. I could start from here as 1 or here as 1, it won't matter. But don't start from here, because if you are starting from here as 1, then you have to go like this: 1, 2, 3, 4, 5. The other double bond is getting position 5. But if I start from here, 1, 2, 3, 4, the other double bond is getting position 4. So this is the correct numbering. In all, there are 7 carbon atoms. So root word is going to be hept, hepta, 1, 4, diene. Since it is cyclic, I'm going to use the prefix cyclo. Cyclohepta 1, 4, diene. Okay, now numbering this compound. If I start from, say here, I'll have 1, 2, 3, 4, 5. That is, I'm getting position 1 and 5 here. What if I start from here? 1, 2, 3, 4. So this is going to be the correct numbering. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let us name this. In all there are 10 carbon. So dec, deca, 1, 4, 7. Triene. Since it is cyclic, use the prefix cyclo. Cyclodeca 147 triene. So this was about the three subparts in the naming, that is root word we have explained, we have understood. We have understood what is a primary suffix. We have also understood what is a primary prefix. Now we can start with what is a secondary prefix. Secondary prefix, it indicates the substituents present on the longest chain of carbon. Now what do I mean by that? Now this compound has a straight chain of 4 carbon atoms. It's a straight chain of 4 carbon atoms, means it doesn't have any substituents. But in case if one of the hydrogen from any of the middle carbon, you replace it by one more carbon atom. So what have I done here? I have replaced one of the hydrogen by a carbon atom. Now this has a substituent. In the sense, I could take maximum 4 carbon atoms here in a chain. I could take these 4 or I could take these 4 in a chain. So the chain here, the longest chain here, can have maximum 4 carbon. So this longest chain becomes the parent chain. Now this carbon is not a part of the parent chain, and if it is not a part of the parent chain, this becomes the substituent. So the carbon atom now which is not a part of the parent chain here becomes the substituent. Name of a substituent is always written as a secondary prefix. Secondary prefix means the naming will always begin with the naming of the substituent. The naming of the organic compound will always begin with the naming of the substituent if it is there in the organic compound. So let us see the name here. First of all, the parent chain has to be numbered so as to indicate the position of the substituent where it is present. Again, numbering here. Since the molecule has a straight chain and with only one substituent, you have to give the priority in numbering to the substituent. Means that the numbering has to begin from that end which is closest to the substituent. So for this compound, the numbering has to begin from this end, because this end if I number, the substituent is getting position 2, and if I start numbering from the other end, the substituent will get position 3. So 2 is a smaller number than 3. So this is the correct numbering. Now let us name this. The parent has 4 carbon. So parent is but. Parent is saturated because no carbon-carbon double or triple bonds. So the parent is butane. Now I'm not going to use any primary prefix here because the compound is not cyclic. But I'm going to use a secondary prefix because the compound has a substituent. Substituent lies on position 2. So the position 2 has a substituent. Substituent itself has only 1 carbon. So for 1 carbon, the root word for the substituent is meth. Since it's a substituent, the name of a substituent will always end in YL. The name of a substituent always ends in YL. So the name of this compound is 2-methyl-butane. 2-methyl-butane. The bond line for this, you can show it as 4 carbon atoms in a zigzag way, and you can show one bond like this to indicate a carbon here. This you could have also shown it here, it means the same. Okay? So the name of the organic compound is 2-methyl-butane. If you look into the numbering here, this will be first carbon, second carbon, third carbon, fourth carbon. 4 carbon atoms in a chain with a methyl branch on the second carbon. So this is 2-methyl butane. Okay, now here also this compound, the longest chain will have only 5 carbon. So this is your longest chain with 5 carbon. You couldn't have taken this chain, because if you take this chain, the chain will have only 4 carbon. So the longest chain here has 5 carbon. Numbering the chain, longest chain, the parent chain could be from any end, because this is again a symmetrical molecule. If you number it from left to right, the position for the substituent is 3. If you number it from right to left, the position of the substituent is still 3. So numbering is not going to matter here. You can number from any end. On the third carbon, I have 1 carbon as a substituent. 1 carbon, so root word is meth. Since it's a substituent, its name will end in YL. So 3-methyl. And now the parent has 5 carbon, so pent is the root word. And since the parent is saturated, the primary suffix for that is ane. So 3-methyl pentane. 3-methyl pentane, the bond line I can show it as 5 carbons. On the third carbon, I have a methyl branch. Okay, so 3-methyl pentane. Now for this compound, again the parent chain here will include the maximum number of carbon atoms, which here are 4. So I could take this as the parent chain with 4 carbon. I could also take this as the parent chain with 4 carbon. I could also take this as the parent chain with 4 carbon, but all 3 are same. So you could select any one. See, if this is 4 carbon chain, there are 2 methyl branches here on the second carbon. If I take this as the parent chain, again the parent chain has 4 carbon with 2 methyl branches on the second carbon. What if I take this as the parent chain? This also has 4 carbon atoms in the chain with 2 methyl groups on the second carbon. So all the 3 chains are exactly the same. You could take any of these as the parent chain. Numbering has to be from the left end here, because that will give you a smaller number to the substituent. Yes, there are 2 methyl branches on this. So you name it as a dimethyl group, because there are 2 methyl groups. The positions have to be indicated twice. So it is 2,2 dimethyl butane. You cannot write it as 2 dimethyl butane, because there are 2 methyl groups, so you have to indicate the position for both the methyl groups. So it is 2,2 dimethyl butane. Again the bond line for this, there are 4 carbon, second carbon has 2 methyl groups. So 2,2 dimethyl butane. This shows the bond line for the compound. Now this compound, again, maximum carbon atoms in the parent chain, I could take it as 4. I could take this as the parent chain of 4 carbon. I could take this as the parent chain. I could take this one as the parent chain. I could even take this. But you can see all the four chains which I have described are exactly the same. So select any of these as the parent chain. Numbering again, left to right is same like numbering it from right to left, because it's a symmetrical molecule. On the second and third carbon, I have 2 methyl groups. So it is 2,3 dimethyl butane. 2,3 dimethyl butane. Bond line 4 carbon. Second carbon has methyl, third carbon also has methyl. So 2,3-dimethyl butane. Let's name this compound now. The straight chain here is the longest chain. You could take this one also or this one also. It's going to be the same. So let us take the straight chain as the longest chain. Numbering now. Numbering, if I number it from left to right. Carbon 2 has 2 methyl groups and carbon 4 will have 1 methyl group. So I'm going to get 2, 2, 4 for the methyl groups. The sum of locants 2 plus 2 plus 4. If I number it from the right side, it will be 2, 4, 4. 2, 2, 4 is going to be the correct numbering. 2, 4, 4 will give me a larger number. So numbering will be definitely from the left end here. So this is 2, 2, 4 trimethyl pentane. 2, 2, 4 trimethyl pentane. This is commonly known as isooctane. Isooctane is petrol. So this is the structure of petrol. Okay? The structure of petrol, which we use as a fuel. Okay, now here the parent chain has 5 carbon atoms. You could take this as the parent chain. You could also take this one as the parent chain, or you could take this one as the parent chain. But again, all the 3 chains are exactly the same. So select any one of them. Let us take this as the parent chain. Numbering again from left to right or right to left will give me the same number for the substituent, that is position 3. Third carbon here has a 2 carbon substituent. 2 carbon means the root word for that is eth. Since it's a substituent, its name is going to end in YL. So it's an ethyl group. The ethyl group lies on the third carbon. So it is 3-ethyl pentane. 3-ethyl pentane. Bond line for this. There are 5 carbon. Third carbon has a ethyl group. So 3-ethyl pentane. Now coming to this compound. This compound, maximum carbon atoms I could take in the longest chain is going to be 5. If I take this as the longest chain, I have 1, 2, 3, 4, 5. 5 carbon chain. What if I take this as the longest chain? 1, 2, 3, 4, 5. So now this has 5 carbons with how many branches? I have 2 branches to this. But what if I select, say, this carbon chain? This carbon chain also has 1, 2, 3, 4, 5 carbon. But the branching to this is only 1. So now I have 2 different chains of equal length here, equal number of carbon. This is one long chain of 5 carbon. This is also one long chain of 5 carbon, but they are different in the sense this chain of 5 carbon has 2 branches and this chain of 5 carbon has only one branch. So how are you going to decide which is going to be the parent chain? Under these circumstances, the rule says that when there are 2 chains having equal number of carbon, then select that chain as the parent chain which has more number of substituents. I repeat, if there are 2 chains in the molecule having equal number of carbon, then select that chain as the parent chain which has more number of substituents. So I have to select this chain, the straight chain here, because that has 2 substituents. And if I take this one, the one marked by red, then that has only one substituent. So this is going to be the wrong chain. So the correct chain is going to be this one because this has more number of substituents. Numbering now. Numbering has to begin from that end, from where the substituents are going to get a lower number. So numbering will begin from here. 1, 2, 3, 4, 5. In all there are 5 carbon. So there is pentane and 2 substituents are there on the pentane. One is a methyl group and the other is an ethyl group. Alphabetically I have to write them in alphabetical order. So I'll be writing ethyl first because ethyl E comes before M of methyl. So it is 3-ethyl because the ethyl is on the 3rd carbon. 2-methyl pentane. 3-ethyl 2-methyl pentane. The bond line for this, in all there are 5 carbons in the parent. 2nd carbon has a methyl, 3rd carbon has an ethyl group. So this is 3-ethyl 2-methyl pentane. Now in this case, the parent chain 1, 2, 3, 4, 5, 6, 7 carbon. 7 carbon chain. So it is heptane. Numbering now. If I number from this end 1, 2, 3. 3rd carbon has a substituent and 5th carbon also has a substituent. What if I number from the right side? 1, 2, 3. 3rd carbon has a substituent as well as 5th carbon. So numbering for the substituents is coming out to be same from either side. So how do I do it now? When the numbering of the substituent comes out to be same from either side, then the higher priority is given for alphabetical order. Ethyl will come before methyl in alphabetical order. So the numbering also here, numbering for ethyl will be before methyl. This rule again you are going to use only when the substituents occupy same positions from either side. Then you give a higher priority to alphabetical order. So this compound is going to be named as 3-ethyl 5-methyl heptane. 3-ethyl 5-methyl heptane. Now let us name this organic compound. Yes, it's swastik. Okay, let us see the naming here. You could take this as the parent chain or this one. It won't matter, it's same. You could also take this one. So numbering 1, 2, 3, 4, 5. There are 5 carbon atoms, so it's pentane. On the third carbon atom, there is one branch here and one branch here, each of 2 carbons. So it's a ethyl group and ethyl group. So third carbon has 2 ethyl groups, so diethyl. 3,3 diethyl pentane. 3,3 diethyl pentane. Let's see the name of this compound. Parent chain, you could take 1, 2, 3, 4. 4 carbon atoms, so it's butane. On the second and third carbon, I have 2 branches, each of 1 carbon. So it's going to be methyl. Since it is repeated twice, it's going to be dimethyl. So 2, 3 dimethyl butane. 2, 3 dimethyl butane. Let's see the name here. 1, 2, 3, 4, 5, 6, 7. 7 carbon in the parent chain, so it's heptane. Now the branches. Second carbon has a branch of a methyl group. Third carbon has 2 branches. Fifth carbon again has 2 branches, and sixth carbon has 1 branch. So in all there is 1, 2, 3, 4, 5, 6. 6 methyl groups as branches. So I'm going to name this as 2, 3, 3, 5, 5, 6. Hexamethyl heptane. Okay, now this compound has both a double bond as well as a substituent. So how do we name this? Double bond will always get a priority over substituent. Okay, double bond always gets a priority over substituent. So numbering will be from that end which is closest to the double bond. So this compound will be numbered from this end because that end is closest to the double bond. So now let us name this compound. The substituent lies on the third carbon. So the secondary prefix is a methyl group, 3-methyl 1-butene, because the double bond is placed on the first carbon. So 3-methyl 1-butene, or you can also name it as 3-methyl but 1-ene. 3-methyl but 1-ene. Both are correct. Bond line for this, 4 carbon atoms. Terminal carbon has a double bond, and on the third carbon I have a methyl group. So 3-methyl 1-butene. Numbering for this compound again. Okay, now one thing to be taken into account here is both the double bonds should be included in the parent chain. Okay, both the double bonds should be included in the parent chain. So numbering will begin from that end, which is going to give you the smallest locants for the double bond. So this compound has to be numbered from this end, because this end will give you the smallest locants for the double bond. The substituent here lies on carbon 3. It's an ethyl group because 2 carbons. So on the third carbon you have an ethyl group. Total carbon in the parent is 6. So it is hex. Hexa 1,4 diene. Diene because there are 2 double bonds. So it is 3-ethyl hexa 1,4 diene. Okay, now let's see the naming for this compound. The parent chain has, I cannot start from here, because if I start from here, 1, 2, 3, if this is 3, this will end here as 4, because if this is getting position 3, this has to get position 4. So numbering, the chain is not going to start from here, the chain will start from here, 1, 2, 3. So this is from where you start the longest chain, 1, 2, 3, 4, 5. Don't go down as 6, because this has to be 6 and then 7. So this is your parent chain having 7 carbon. The second carbon has a ethyl group, third carbon has a methyl group, and the fifth carbon again has a ethyl group. So let us name ethyl before methyl. There are 2 ethyl groups, so we name them together as diethyl. It is 2,5 diethyl, 2,5 diethyl, 3 methyl, 7 carbon, so root word hept, hepta 1,5 diene. Diene because there are 2 double bonds. So this is the IUPAC name of the compound, that is 2,5-diethyl 3-methyl hepta 1,5-diene. Okay, now this compound comprises of 2 parts. You have a cyclic part in the compound and you also have a side chain. This is called as the side chain. Side chain is the open chain part and you have a cyclic part. Now the cyclic part here has 6 carbon and the side chain, that is the open chain part, has only 2 carbon. So treat them separately. One is to be taken as the parent and the other is to be taken as a substituent. Of course, the one which will have more number of carbon is going to be taken as the parent. Yes. So the parent here is the ring system because ring has 6 carbon. So it is going to be cyclohexane. The parent is cyclohexane. This is going to be taken as a substituent. There are 2 carbon in the substituent, so it is ethyl. Ethyl cyclohexane. One is optional here, writing 1 ethyl cyclohexane. It's not compulsory because wherever the ethyl group is there on the ring, there is only 1 ethyl group. So the numbering will always begin from that carbon which is having the ethyl group. Okay. So 1 is optional. You may write 1 or you don't write 1, it's the same. Again, now this compound has two parts. One is the cyclic part here, having 3 carbon, and the open chain or the side chain has 5 carbon. So definitely the open chain or the side chain is going to be taken as the parent because it has 5 carbon. Numbering of the parent here could be from any end because you're going to get the same number for the substituent. From right to left or from left to right, the numbering for the substituent will come out to be same. Now the substituent here lies on the 3rd carbon. 3rd carbon, so it's going to be 3-cyclopropyl. Propyl because 3 carbon, prop because 3 carbon, and YL because it's a substituent. And total carbon in the parent chain are 5. So it is 3-cyclopropyl pentane. 3-cyclopropyl pentane. Now again this compound has a ring part and an open chain or the side chain. Ring has 4 carbon, side chain also has 4 carbon. So if the ring has 4 carbon and even the side chain has 4 carbon, same number of carbon. So if same number of carbon means definitely the rule says here that the ring will be the parent. So if you have equal number of carbon in the side chain as well as in the ring system, then the ring is taken as the parent. So parent is going to be cyclobutane. This is going to be named as a substituent. So it's butyl cyclobutane. Butyl cyclobutane. But now if the side chain has something like a double bond, now the side chain becomes the parent chain because it has a double bond. So now numbering again from which side? If I number from this carbon, 1, 2, 3, 4, double bond gets position 2 and substituent gets position 1. If I number from this side, 1, 2, 3, 4, double bond is still getting position 2, but substituent is getting position 4. So I have to see that when double bond is getting the same position from either end, now the next priority is going to be for the substituent. So substituent also should get a lower number. So numbering is going to begin from this end. The first carbon has a substituent. So it is 1-cyclobutyl. 1-cyclobutyl 2-butene or butene. 1-cyclobutyl 2-butene or butene. Now in this case, both the ring as well as the open chain have a double bond as well as same number of carbon. Both have double bonds as well as same number of carbon. So now again the ring will be taken as the parent. So numbering for the ring, a double bond is going to get a priority over substituent always. So for numbering, a double bond always gets a priority over substituent. So numbering has to begin from the double bond. I could number this as 1, 2, 3, 4. If I number it like this, I get position 4 for the substituent. But if I number it like this, I'm going to get position 3 for the substituent. So this is the correct numbering. It is cyclobutene with a substituent lying on the third carbon. Third carbon has a substituent. Now while numbering the substituent here, because substituent also has a double bond, so I have to indicate the position where the double bond is there in the substituent. So while numbering the substituent chain, always remember the carbon of the substituent which is directly connected to the parent, that is always its first carbon. The carbon of the substituent which is directly connected to the parent is always taken as the first carbon. So this is the first carbon, this becomes the second, third and fourth. It's a 4 carbon chain, so it's a butyl group but with a double bond. So it is, instead of butyl we'll be writing here as butenyl. Ene, why? Because it has a double bond. And where is the ene present now? The ene is present on the second carbon of the substituent chain. So on the third carbon of the parent chain, I have but2enyl. But remember this number, this numbering is that of the substituent chain and this numbering is of the parent chain. So please separate it by adding a round brackets here or parenthesis. So parenthesis is added here to separate these two numbers. This number is of the substituent chain and this number is of the parent chain. So the substituent chain has to be now put inside the round brackets. So this is 3-but2-enyl cyclobutene. Again writing cyclo-1-butene or cyclobut-1-ene is going to be optional, because if I change the position of the double bond, it's actually not going to change that position of the double bond, it is going to change the position of the substituent. Means what? Means supposing if I have this compound and if I have this compound, it appears to me that I have changed the position of the double bond, but it is actually not. It has changed the position of the substituent here, because double bond is always going to get position 1 here. So the substituent position here is 4 and here the substituent position is 3. So shifting the position of the double bond, actually not shifting the position of the double bond, it is shifting the position of the substituent. So double bond will always get position 1 here. So here also double bond will always get position 1. So writing it as cyclobut-1-ene is not compulsory, because I know that cyclobut-1-ene is same as cyclobutene. 1 is not compulsory there, because wherever the double bond is going to be there, that is going to be carbon 1. Okay. Okay, now for this compound, I have to include both the double bonds in the longest chain, even though it is not the longest chain. I know this chain will have more number of carbon, but then the double bonds have to be included in the parent chain. So the parent chain here comprises of 5 carbons. Numbering for the parent chain again could be from any end, because this molecule is again symmetrical. Both the double bonds are equally spaced out, and even the substituent, either if you number from right to left or left to right, gets the same position. So now numbering for the parent chain could be from any end. So the parent chain has 5 carbon. It is penta 1,4 diene. That is the parent chain. Now coming to the substituent chain. In the substituent chain, the longest chain in the substituent could include only 3 carbon. Either these 3 or these 3, but both are same. So the longest chain in the substituent here can include only 3 carbon. So it's a propyl group. But then you also have one more carbon as a branch on the substituent. So it's a substituent which itself is substituted. A substituent which itself is substituted is called as a complex substituent. Now, naming of complex substituent is always done inside a round bracket. Okay, so let us name this compound. On the third carbon of the parent chain, I am having a complex substituent. Complex substituents are those which themselves have substituents. So a substituent having its own substituent is called as a complex substituent. So now let us see this. The numbering of the substituent chain. The carbon of the substituent which is directly connected to the parent chain is always the first carbon. So this is going to be the second and this is going to be the third carbon. So it's a propyl group with a methyl substituent on its second carbon. So substituent is always written before the parent. Like for this propyl group, the parent is going to be this. But for this methyl group, the parent is going to be the propyl group. So methyl is to be written before propyl and propyl is to be written before this parent. So let us see. On the second carbon of propyl, I have a methyl group. So it is 2-methyl propyl. A 2-methyl propyl group is present on the third carbon of the parent chain. Parent has 5 carbon. So it is penta 1,4 diene. Penta 1,4 diene. The bond line I can make it. This is the third carbon with 3 carbons, 1, 2, 3, and there's a methyl branch here. Now let's see the naming of this compound. I have to include both the double bonds in the parent chain. So 1, 2, 3, 4, 5 and 6. I started from this end because the double bond should get the lowest number. So this is the parent chain. The substituent chain, this is going to be the first carbon which is directly connected to the parent. This is the second carbon and this is the third carbon. So on the third carbon of the parent chain, I have a complex substituent. The complex substituent has 3 carbon atoms in a straight chain. So it's a propyl group with a methyl branch on the first carbon. So it is 1-methyl propyl. 6 carbon atoms in the parent chain. So it is hexa 1,3-diene. Hexa 1,3-diene. Okay, now let's see the name of this compound. The parent is going to be the ring because there are two double bonds. Numbering has to begin from any of the double bonds. You could start from here as 1 or here as 1. But don't go from here as 1, 2, 3. Because if you start from here, the substituent will get a higher number. Though the double bonds will get the same position. If you start from here, the double bonds are going to get the same position, but the substituent also will get a lower number. So numbering can be from any of these carbon. This is 1, 2, 3, 4, 5, 6. For the substituent, the numbering is going to be like this. Okay. So now the substituent again here lies on the third carbon. Substituent is a propyl group. It has a double bond. So it's a propenyl group with a methyl branch on its second carbon. So second carbon has a methyl branch. So 2-methyl prop 1-enyl. 1-enyl because the double bond is placed on the first carbon. The double bond could also have been on the second carbon if it was like this. So indicating the position here is compulsory. So it is on the third carbon of the parent chain where you have this propenyl group. The propenyl itself has a branch here on the second carbon. So 2-methyl prop 1-enyl. And then the parent, which is cyclohexa 1,4 diene. Cyclohexa 1,4 diene. I'll take one more structure. Let's see the name of this compound. Parent is of course going to be the open chain because it has two double bonds. So numbering you could do from any side because it's a symmetrical molecule. Positioning of the double bond as well as of the substituent is the same from either side. Now the substituent, this is the first carbon. The substituent again lies on the third carbon of the parent chain. It's a cyclobutyl group with two methyl groups on its third carbon. So it is 3,3 dimethyl cyclobutyl. 3,3 dimethyl cyclobutyl, and then the parent has 5 carbon. So it is penta 1,4 diene. Penta 1,4 diene. So now till here we have actually completed 4 parts of the naming. That is the IUPAC 4 parts we have completed: the root word, then the primary suffix. We also did what was a primary prefix and a secondary prefix. The only part remaining now to explain is the secondary suffix, which is the functional groups, which I'll be taking in my next class. Okay, thank you. कितने बच्चे थे?